All right, so I'm finishing Unit 2 in this video. So we're moving on to another proof for question 8, where they're giving us a parallelogram. Now, that is a really nice given if we're just trying to get points on this. What I mean by that is once you know that it's a parallelogram, you have opposite sides that are equal. So you could tell me BA is congruent to CD. You can tell me BC is congruent to AD because opposite sides of a parallelogram are congruent. You can tell me angle A and angle C are congruent. There's all sorts of stuff you can tell me that are congruent. We have a ton of nice givens here because we're also given that we have perpendicular sides. So when you're given perpendicular sides, you can say that you have 90-degree angles, or you can also say you have congruent angles, and that would be because perpendicular lines make congruent right angles. And then we have CE congruent to CF. So I'm going to go ahead and start marking. Remember, you can use highlighter on the exam. Now, whatever's in the highlighter you cannot get graded on, but as long as what you want graded is in blue or black pen, you're good to go. Having said that, blue and black pen are also useful because that gives you different colors. This isn't the best blue pen, but it at least still gets the idea across. Okay, so here we go. It proved that it's a rhombus. So I'm proving if I saw diagonals, I might be thinking that diagonals are perpendicular, but otherwise right now I'm thinking I need to get all 4 sides equal. So I definitely need the sides in my proof. Okay, so to start this proof, and I know I'm kind of moving around here, sorry. So statements and reasons. Two S's and reasons, definitely how you spell that. Okay. So parallelogram ABCD is my first given. And I'm going to write them separately today. Sometimes I write them all at once. But I want to show you. So again, if you're given that, you can now tell me that AB is congruent to CD because those are opposite sides in a parallelogram. Remember, we mark them like this often. And then I'm going to, in the same statement, because I'm using the same reason, I'm going to say BC is congruent to AD. So, and BC is congruent to AD. That's because opposite sides of a parallelogram are congruent. Okay, so far I have opposite sides congruent, but now I need to get consecutive sides congruent, okay? So that's where I'm working through. Now remember, they told me that I have perpendicular lines in here, okay? So that might be the next place I go. Like, okay, so right now I'm going to use that with the parallelogram. Maybe I'll come back to that given, but now I'm going to say BE is perpendicular to CED, and DF is perpendicular to BFC. And you know what? I'm going to throw CE is congruent to CF in there just so that it's in there and I don't forget to put it in later, that last part of the given. Okay. This is just there. This is a side. Unless I'm getting anything out of it, really, that's just 2 sides. It might help me kind of focus on some triangles, but right now I just know that I have that piece and that piece. Okay. From here, I need to decide where I'm putting my right angles. If you don't know, put them everywhere that they exist. For instance, they're on both sides of F and both sides of E. I'm going to be a little bit more strategic and decide which ones right now. So I'm focusing, and again, you can use the blue and the black. My attention is immediately focused on this triangle because they gave me CF. So I'm seeing that CF is a part of this triangle and that CE is a part of this other triangle here. So those I just decided are the 2 triangles I'm going for. Therefore, this angle, CFD, I'm going to give an indication of angle 1. And this triangle, CEB, I'm going to give an indication of angle 2. So I'm going to now say angle 1 is congruent to angle 2. Perpendicular lines make, here's where you need to be careful, congruent right angles. Otherwise, you have to do a couple steps there to get that point across. All right. So now I have a side, an angle, and now I gotta figure out another piece of this puzzle. Maybe you see vertical angles, you're not wrong if you throw that in there. But I need to get another angle or side. I have no other sides. I can't use that. So now I start looking at the angles. This angle and this angle, I have no, like there's no parallel lines there, that there's no alternate interior angles, so that can't do it. But angle C, I'm hoping you notice, is in both triangles. So angle C is in this triangle, and angle C is also in this triangle. So that's my last piece that I need, and that's the reflexive property. I know it's usually a shared side, but you can have a shared angle as well with reflexive property. So that's reflexive property. And now I can say that the two triangles are congruent. So I'm still here with S and R. So number 6, I'm going to say triangle CFD is congruent to triangle. So I did CFD. I'm going to go CEB. So I say them in corresponding order. And my reason, if I cover one to kind of focus on it, I have two angles and a side. The side is in between the two angles, so that is angle, side, angle. And then always CPCTC will follow. Now I have to be strategic. I'm trying to prove that it's a rhombus, so I'm trying to prove that all the sides are equal. Well, I just kind of showed what I need. I need BC and CD congruent. Those are the two corresponding parts of those triangles that I need, because those are the sides of the rhombus. Okay, so now I can say that ABCD is a rhombus. And the reason would be it is a parallelogram. Now, if all you can think of is with 4 congruent sides, like I support you, but the way I just proved it is I need to say it's a parallelogram with a pair of consecutive sides congruent. That would force a rhombus to happen. There's no other way for that to occur. So I'm going to write it out just like that. But again, if all you can think of is that as 4 sides, go for it. Okay. Next one, another proof. This is lots of proofs in this part of the unit. So question 9. Given parallelogram ANDR with AWDE bisecting. I'm definitely underlining that word right away. Parallelogram we talked about in the last proof. We need to prove that these two triangles are congruent, and then also that it's a parallelogram. So this is nice because they kind of mapped it out for you. They told you which order to go in, which is kind of helpful. So I'm going to start here with, again, my given. So parallelogram, this is the symbol for parallelogram. You are allowed to use that symbol. ANDR, that's given. Okay. So now I'm going to focus my attention on these triangles. So ANW and DRE. Well, automatically, I see my sides there, so I'm going to use those from my parallelogram, because the fact that I know that that's a parallelogram tells me that AN is congruent to DR. Oh, that's a 2. Opposite sides of a parallelogram are congruent. Okay. Now, before I move on to my next given, I'm just going to double check. Is there something else I can use in those triangles from the parallelogram? So I have this already. I also can use angle N and angle R, because those are opposite angles in a parallelogram. So luckily, I had a given that I could use more than one piece of information for. So angle R is congruent to angle N, and that would not be opposite sides, right? That's opposite angles in a parallelogram are congruent. Moving on to number 4. I need another side, or I need another angle, right? I need something. So I'm seeing that this is half of that, or at least they think. And I'm right, because right here. So this is my next given that I'm going to write. And I'm going to write it exactly as it's worded, even though it's kind of worded awkwardly. In my personal opinion, I like to just say them separately. REA at points W and E respectively. respectively. Okay, given. So what that tells me is that AE is congruent to ER and NW is congruent to WD. I marked them all the same because in a second I'm realizing that I'm gonna connect that to the parallelogram. So first I'm just gonna start with that. AE is congruent to ER. NW is congruent to WD. 5, a bisector cuts a segment into 2 congruent parts. Okay, I'm gonna move over here now. So I have these congruent, but I still don't have NW, this piece, congruent to ER, and that's the last piece I need to be able to prove these 2 triangles congruent. So I need to get that going. And I'm going to do that through the parallelogram. So I'm going to say that ER is congruent to NW. And looking ahead to the fact that I'm going to have to prove that this is a parallelogram, and I'm going to use the same reason, I'm going to say AE is congruent to WD. Okay? My reason for that, you could say this a bunch of different ways, but, oh, I need to add a 5.5. I forgot to say my piece. Oh, I'll put it right here. So I'm also going to say in statement 2, AN is congruent to RD, so is AR and ND. So I'm just going to throw those in here because it's the same reason. It's the opposite sides of a parallelogram are congruent. Now I can say this. So basically I have 2 congruent parts of congruent sides. So bisected pieces of congruent sides are congruent. Okay, not the best language that I could have used probably, but still effective. I have bisected pieces of congruent parts, and therefore they are congruent. And that is exactly what's happening, right? These are 2 halves of the same whole, so they have to be the same. I now have side, angle, side. So now I know that that will go here, which means CPCTC will follow. So triangle ANW, that was step 1. And what they were trying to have us prove, triangle DRE. Okay, that part's done. What do I need to prove it's a parallelogram? Well, I already have AE and WD. Now I just need AW and ED. And luckily, those are the third side of my triangle, so that's what I'm going to use CPCTC for. So ED is congruent to AW. That's my CPCTC. And now I can say that AWDE is a parallelogram. And that's because a parallelogram has 2 pairs of congruent opposite sides. That's what I proved. I proved that AE and WD are congruent, as well as ED and AW. These proofs are definitely not small. These would be like 6-pointers. Number 10, in the quadrilateral, we're given congruent sides. So again, I'm going to start labeling as I read. Quadrilateral tells me I can't use all those fun parallelogram aspects right now. So it means I'm limited compared to the last 2 we did. So AB is this entire bottom, is congruent to CD. AB is parallel to CD. Well, guess what? They just gave me my parallelogram. I just have to say it. Okay. Once you have one pair that is both congruent and parallel, that shape is definitely a parallelogram. Okay. BF is congruent to DE, so I also have this little piece and this little piece. So right now I'm seeing this triangle, and I'm also seeing this triangle. So before I go any further, I'm actually going to look right down here at what I'm trying to prove to kind of bring my attention to it a little bit better. So AE and CF. Okay, so we'll have to decide, well, I'll have to decide what I'm going to use that for. And actually, there's probably 3 different ways you can do this proof that are coming to mind. So I'm just going to do the one that I think is the easiest. BF and DE are both perpendicular to AC. So there's my right angle here, and there's my right angle here. So, yep, I made my decision. This is gonna be, in my opinion, the easiest way. I'm gonna go for these two triangles right now. Because they're right triangles, I can use HL. And that's what I'm actually gonna use to solve this. So I'm gonna first say that this entire shape is a parallelogram. And then, actually, let's do angle side. That's faster. And then I'm gonna go to this angle here, 1, and this angle here with my alternate interior angles. And then it'll just be an angle side proof. Okay. But HL would work, you just have to say that it is a right triangle. And then as long as you have a hypotenuse and a leg, you're good to use HL. So here we go. Statement number 1. Again, walking you through my logic here. Quadrilateral ABCD. And I'm going to bring the first two things because that's how I'm going to introduce the parallelogram. So AB is congruent to CD. AB is parallel to CD. So that's my first given. I'm going to bring the rest of the given in, of course, but this is just how I'm starting my proof. I'm using that to say that this entire shape, so A, B, C, D, is a parallelogram. That's my next statement. And it's a quadrilateral with one pair of opposite sides, congruent and parallel. Okay. Hopefully you can see my writing a little bit better. This page has a lot more room. I wanted to use that because I want to say that AD is congruent to CB and they're also parallel. So I'm going to say AD, I'm going to say both of those things, is congruent to BC and AD is parallel to BC. A parallelogram, it's almost the same thing as statement 2, has congruent and parallel opposite sides. Okay, so in my angle side proof, I have already, even though it looks like there might be more, I have my side taken care of. Oh, actually, I just did an extra side. I didn't need that side. Oh, that's fine. So I still need this one. This was the side I was going for. But I don't have any of these yet. If you're looking, like, what the heck? So that is where I'm going to do an angle now. And that's going to be angle 1 is congruent to angle 2. And those are alternate interior angles are congruent when lines are parallel. And now an angle is out of there. Okay, back to the givens. I fully went through my thought process of getting one of those angles. Now I'm going back to the givens to get the rest of my information. So my next given are that BF and DE are perpendicular to AC at F and E. Oops, sorry, you can't see that. Given. And again, I'm using that to be able to say that angle DEA is congruent to angle BFC. I could have named them 3 and 4. I'm just reminding you the proper way to name angles. Those are congruent because perpendicular lines, again, be careful, congruent right angles, not just right angles, congruent right angles. Okay, so I have my congruent angles for the other one. If I was doing an HL proof, I wouldn't say that they were congruent here. I would say that they are both right angles, and perpendicular lines make right angles. Because for an HL proof, I need a right triangle. All right, so the other angles then, now I need that side, and that came from the given, did it not? BF and D are perpendicular. Oh, no, they're not. I just made that up, didn't I? Oh, that's what I'm trying to prove. Okay, so I think I do need my HL. DE are perpendicular to AC, AB congruent to AC. I'm just making sure. When did I mark those congruent? I'm talking about BF and DE. They are perpendicular to diagonal, but it never said they were congruent. Okay, so I was just having a thought there, apparently. So that's fine. So far I have angle, and I am going to use CB and AD. So it's a good thing that I have that in there. So CB, these are not my congruent sides. These are my congruent sides, which I already have in my proof. So CB and AD, angle, side, angle, side still works. So I have officially made it to angle, side, and triangle AED. Just trying to keep the picture in it at the same time. It's kind of challenging. Triangle AED is congruent to triangle CFB. And CPCTC is going to follow. And that is going to be what I'm trying to prove, which is AE is congruent to CF, which again, they're corresponding. There they are. So there is that proof. Again, there's definitely other ways to do that, but that is the thought process I had going. Okay, moving on to just questions about shapes for the most part. A parallelogram must be a rectangle when you want to know this about a rectangle. Its diagonals are congruent. That's like a gimme, okay? If not, draw it out, right? Draw a rectangle. Use your graph paper to draw a rectangle, because then you'll really see when you measure the diagonals that they are congruent. They're definitely not perpendicular. Those aren't right angles. Opposite sides are parallel, yeah, but so that they are in a parallelogram, etc. as well. Opposite sides are congruent, yeah, but they are in a parallelogram, and a rhombus, and a square, etc. Here we have diagonals intersecting in a parallelogram. Which statement does not prove it's a rhombus? So the diagonals should be perpendicular in a rhombus, so this one's out, because it says which one does not prove. That is a clear thing about a rhombus. Another clear thing about a rhombus is that the diagonals bisect angles, so that one is out, because that is true. So again, if I draw my rhombus, which has 4 equal sides, maybe I use my compass to help me through this a little bit, but this is just for sketch. I know that I have right angles here. I know that all of these triangles are equal. So now I just try to, so AC and BD. AC is congruent to DB? No, that happens in a rectangle. There it is. Diagonals are congruent in a rectangle, not a rhombus. Segment CD is the perpendicular bisector of AB at E. So CD bisects. Now it didn't say anything about it being congruent, but AB is congruent. So I'm going to purposefully draw it like this, because CD is cutting AB in half. It doesn't say AB is doing anything. Which pair of segments does not have to be congruent? So this is why I think outside the box kind of with these, because I want to make sure my drawing doesn't force something to happen that shouldn't. So AD and BD are definitely congruent. That's an isosceles triangle. This is E. That's an E. AE and BE, definitely congruent. AC, BC, again, definitely congruent. They're all stemming from that midpoint there. DE and CE are not. Everything else is going horizontally from that midpoint. That's going vertically. That is not a midpoint for CD. So that is why 4 is the correct choice. Another quadrilateral with diagonals. Which one is not sufficient to prove it's a parallelogram? Diagonals bisect each other in a parallelogram, so that definitely is sufficient. So if I draw my parallelogram out, okay, this is what I should see. So AB is congruent, ACBD. AB is congruent to CD, and BC is congruent to AD. That would force it to happen. This is that same and different thing I talked about in class. I have this different symbols, but the same sides. So that would prove it. Here I have different symbols and different sides. That would not prove it. That would create that trapezoid. Question 5. A parallelogram is always a rectangle if the diagonals are congruent. Okay, it came up again. They like that question. Use a compass and a straight edge to construct an inscribed square in the circle shown below. Okay, so I am going to use a pen right now, but as a reminder, anytime you're on this page in a Regents exam, this can all be done in pencil, especially, obviously, this part. So a square, you just make a diameter. You go more than halfway. You bisect that diameter. And after you bisect the diameter, there is a slight chance that you can make a mistake, so please make sure you don't. People will just accidentally connect the wrong points. So like people will connect here to here to, no. It's the points on the circle that you're gonna connect to make your square. So this is how you should be connecting it. And again, this can all be done in pencil. Everything I'm doing right now is on a drawing or a construction, and that is allowed to be done in pencil on the exam. So there you go. All right, quadrilateral ABCD is a parallelogram, the diagonals intersecting, and we need to prove the two triangles congruent. All right, so I'm just gonna start, it was a pretty basic given, so I'm just gonna start by writing that given, and then we can get going with our logic. This should be pretty basic, just at first glance. I could be wrong, but here we go. So ABCD is a parallelogram with diagonals A, C, and B, D intersecting at E. Again, write it all down. Even if it's like, of course they are. Write it down. Given. That was a really messy given. Okay, I need to prove, so again, I'm going to draw my attention to them. I need to prove triangle AED congruent to triangle CEB. And I'm going to do it all with properties of parallelogram because that's what they gave me. For those of you who are just looking at this, those should definitely be in there. They're actually not necessary. You can do it without them, but I know that you guys know how to spot vertical angles really well, so we are going to put those vertical angles are congruent in our proof. Okay, so I have an angle so far. I'm going to get a side from here and here. So AD is congruent to BC. Opposite sides of a parallelogram are congruent. And then for number 4, I'm going to get, how am I going to do it? Probably the alternate interior angles is what I should do. So I'm going to say are congruent and parallel. Quick edit to the one before. And I'm then going to say that AD is parallel to BC. So now if I follow a Z, I can use these two angles or those two angles. I'm just going to pick these two. So angle 3 is congruent to angle 4. Alternate interior angles congruent when lines parallel. And there are at least 3 different ways to prove these triangles. So if you did it a different way, you're probably just fine. So triangle AED is congruent to triangle CEB. And I just used angle side. Describe a single rigid motion that would map AED onto triangle CEB. That would be a rotation about point E 180 degrees. And this could either be counter or clockwise, but I'm just going to go with counterclockwise. Okay. Question 8. Given quadrilateral ABCD with our diagonals that bisect each other, ooh, it's a parallelogram, and angle 1 is congruent to angle 2, prove that triangle ACD is an isosceles triangle and AEB is a right triangle. So that right now screams to me rhombus because those are properties of a rhombus. Okay, so I gotta start getting my stuff here. So I have a quadrilateral with diagonals that bisect each other, so I'm going to start there so that I can say that this shape is a parallelogram. So statement 1, quadrilateral ABCD with diagonals AC and BD that bisect each other. Okay. Now I'm going to say that's the given. So now I can say that ABCD, I don't know why I wrote a line over it, is a parallelogram. Parallelogram. Diagonals bisect each other. I'm going to go straight to that next given. Angle 1 is congruent to angle 2. Given. I'm going to use the fact that the diagonals bisecting the angles to prove that this is a rhombus. So now I'm going to say that AC is an angle bisector of angle BAD. So that is a bisector cuts an angle into two congruent parts. And then I might even be like, i.e. angle 1 and angle 2. Like just in case someone's reading this and like, where are you going? Like those two angles, we're just cutting angle BAD into two congruent parts. And then I can say that it's a rhombus. So ABCD is a rhombus. A rhombus is a parallelogram with diagonals that are angle bisectors. Now I'm using a ton of quadrilateral properties right now. Rhombus is a parallelogram with diagonals that are angle bisectors. So I get if you're like, whoa, what? These are all properties we've learned. I'm just using them a ton. There are probably other ways to get through this proof. This is just where I'm going. Now that I know this shape is a rhombus, I think I'm just a couple steps away. I'm going to say that AD is congruent to CD. That's really messy. That says AD is congruent to CD for the record, right there. A rhombus has 4 congruent sides. I'm going to say that BD is perpendicular to CA. A rhombus has perpendicular diagonals. And then I'm going to say that angle, I'm focusing here, AEB is a right angle. Perpendicular lines make right angles. And then I'm going to say my last two statements, which are here and here, because I've gotten that far. So I'm just running out of space, so I'm going to say it. Statement 9 is triangle ACD is an isosceles triangle. My reason for that is isosceles triangles have 2 congruent sides, and I already got those right here in statement 6, AD congruent to CD. Statement 10 is going to say that triangle AEB is a right triangle. My reason is a right triangle contains a right angle, and again, in my proof, I proved that angle AEB is a right angle. So that is Unit 2. Have a great day.